B31 Atlas, the interstellar mystery getting weirder by the day. Take a look at this next report for more details.
It began on a night when the sky seemed to fall silent. Across the great observatories of the world, domes that once turned restlessly toward the stars stood still. Screens that usually glowed with live images from deep space went dark, their feeds suddenly cut off without warning. Astronomers waited for updates that never came, and for a few uneasy hours, it felt as if the universe itself had stopped talking. But far away in a quiet Chinese observatory, a small team kept their eyes open. Through the silence, their instruments detected something faint yet persistent, a distant glow moving against the stars. They didn't know it yet, but they were watching 3I Atlas, an interstellar traveler that didn't belong to our solar system. While the rest of the world saw nothing, their cameras recorded what would become the most controversial images in modern astronomy. No press release, no international coordination, only stillness broken by the soft hum of machines collecting data no one else could see. That night would mark a shift not only in science, but in who holds the keys to the heavens. And the question remains, why did every Western telescope go dark at the exact same moment the universe decided to reveal something new? Before the silence, there was excitement. Astronomers across the world had turned their telescopes toward a small moving dot that didn't follow any known path. It was called 3I Atlas, the third interstellar object ever discovered, and it came from somewhere far beyond our solar system. Unlike ordinary comets that circle the sun, this one was just passing through, moving too fast to ever return. From the start, it seemed different. Its bright halo wasn't made of the usual frozen water vapor, but thick streams of carbon dioxide and organic dust glowing faintly under sunlight. The James Webb Space Telescope confirmed the strange mix, detecting traces of water, carbon monoxide, and other molecules that had never appeared together in any known comet. To scientists, it felt like a message carried across light years, a fragment of another star system drifting through ours. As it moved closer to the inner solar system, observatories from Hawaii to Chile followed its trail, trying to capture every possible image before it disappeared again into the dark. It wasn't just a discovery, it was a race against time. Every photograph, every spectral reading could be the last glimpse of something humanity might never see again. Then, just as 3I Atlas approached its brightest phase, the unthinkable happened. Major Western telescopes went offline, leaving the world's view of the object suddenly blind. And in that blind spot, someone else was already watching. Could it be coincidence, or had another nation been waiting for this exact moment? When the world expected a flood of new data from the skies, nothing came. For the first time in years, the major Western observatories, Hubble, the Very Large Telescope, Gemini, and even the mighty James Webb fell quiet. It began with simple maintenance notices, short updates saying certain systems were under calibration or temporarily offline. But as days passed, those temporary delays stretched on, and astronomers realized something unusual was happening. The sky had gone silent, and no one could explain why. In Hawaii, the Atlas network that first detected the interstellar traveler stopped releasing images. In Chile, where some of the clearest views of the cosmos are recorded, telescope schedules were suddenly reshuffled without public notice. Even the European Southern Observatory reported technical adjustments, leaving entire nights unmonitored. For scientists who live by data, that silence was almost unbearable. Some called it coincidence. Others whispered that the timing felt too perfect, too coordinated to be random. After all, it happened just as 3I Atlas reached a critical phase of its journey, its approach to perihelion, when the comet would be brightest and most active. That was the moment the world should have been watching. Yet the West's greatest eyes had blinked. Across online forums, questions began to surface. Why did all these telescopes go offline at the same time? Why now, of all moments, when a once-in-a-lifetime object was passing through the inner solar system? Speculation turned into frustration. Astronomers from smaller institutions complained that observation requests were being ignored. Some said access to public databases had been delayed or restricted. A few researchers claimed their scheduled observation slots were canceled at the last minute, replaced with vague administrative priorities. The sense of mystery deepened. If it were truly maintenance, why not release the raw data collected earlier? Why was everything so quiet when transparency is the foundation of science? Meanwhile, journalists began to dig. Freedom of information requests to NASA and the European Space Agency yielded generic replies citing ongoing system upgrades. No one wanted to say the words out loud, but a growing number of people suspected data suppression. Could it be that the observatories saw something too strange to publish? On social media, amateur astronomers from Australia and South America tried to fill the gap. Their equipment was limited, but they reported unusual brightness spikes coming from the region where 3I Atlas was last seen. Some described what looked like a faint double flare, as if the object were pulsing or releasing energy. Without official confirmation, the community was left guessing. Each new amateur image was shared thousands of times, debated, and dissected like a digital crime scene. Still, none of it could replace the precision of professional instruments. The world wanted answers, and the silence from the West only made the mystery grow louder. Then came the strange part. While NASA's channels went dormant, several tracking stations in Asia continued transmitting signals as if nothing had happened. They weren't sharing details, but their frequencies showed active tracking operations. It was clear that someone, somewhere, was still observing. And soon, the first whispers began to point east. Reports leaked that a series of powerful Chinese observatories had continued their surveillance of 3I Atlas without interruption. When asked, officials declined to comment, but insiders confirmed that the images were clearer than anything the world had seen so far. The silence of the West had created a vacuum, and China was stepping into it. What began as a technical pause was becoming something far bigger, a global shift in who held the power to watch the universe. And as rumors spread of new high-resolution frames emerging from Beijing's data centers, one question echoed everywhere. Was this simply timing, or had someone planned for the West to go blind? While the Western world struggled to explain the sudden blackout, a quiet operation was unfolding far to the east. In the mountains of Yunnan and deep within the deserts of Xinjiang, several Chinese observatories remained fully active. Their domes turned through the night, following the same coordinates that Western telescopes had abandoned. Inside, rows of computers processed a steady stream of data light curves, dust readings, and faint infrared signatures from a single source: 3I Atlas. Unlike the silence in the West, These facilities showed no sign of interruption. Chinese scientists had prepared for this moment long before the world realized its importance. Their network of automated telescopes, supported by artificial intelligence and fast relay satellites, allowed continuous observation without delay. When the first new images appeared on their monitors, the scientists knew they had captured something no one else had: the only living record of a cosmic visitor passing through Earth's neighborhood. The images showed 3I Atlas in remarkable clarity. The comet's coma glowed brighter than ever, its tail stretching like a thin thread of silver against the blackness. More intriguingly, there were changes in its shape. One side appeared denser, with a plume of material rising unevenly, almost as if something beneath the surface had erupted. The timing was extraordinary. These frames were taken at the exact moment when Western telescopes went dark. For days, the Chinese team analyzed every pixel. They noticed faint variations in brightness repeating at regular intervals, suggesting some kind of rhythmic behavior. At first, they thought it was a rotation pattern, but the intervals didn't match typical comet spin rates. It seemed to pulse, almost like a heartbeat. The data was sent to Beijing's National Space Science Center for confirmation. Within hours, encrypted transmissions began moving between observatories and government research labs, carrying the most valuable dataset of the year. Meanwhile, outside observers began to notice unusual radioactivity over Asia. Amateur radio networks detected bursts of data signals matching frequencies used for deep space communication. It was clear that something significant was happening behind closed doors. When rumors spread that China had captured new, high-resolution frames of 3I Atlas, speculation exploded online. Some believed the government had simply taken advantage of Western downtime. Others claimed they had been waiting, perfectly positioned to seize this window. The release came suddenly. Without prior notice, China's National Astronomical Observatory published a series of images showing 3I Atlas in motion, each labeled with timestamps overlapping the period when the West was offline. The photos showed a glowing sphere surrounded by asymmetric halos, jet-like streaks of gas, and a curious bright flare pointing toward the sun. To the scientific community, it was a revelation. For the media, it was a shock. Headlines spread across the globe. China captures what the West missed. The timing, the clarity, the precision, it all looked too perfect. NASA and the European Space Agency issued short statements acknowledging the release, but offered no comment on their own missing data. For the first time, China had the exclusive attention of the global astronomical community. They were no longer following, they were leading. Inside international forums, debates erupted. Could the brightness patterns in the images mean something new about interstellar comets? Did the sun trigger the flare, or was there an internal energy source inside the object? Without alternative data from Western telescopes, the Chinese interpretation became the official one by default. Scientists from other nations were left with a choice: accept the Chinese results or wait indefinitely for more evidence. What began as a scientific observation was quickly turning into a political earthquake. The shift in control over the skies had begun, and the world could only watch. But the most unsettling part was yet to come, because what those images revealed went beyond science itself. The moment China's images of 3I Atlas were released, the world froze. At first, they seemed like ordinary comet pictures, bright dust clouds and glowing tails, but scientists soon noticed something unusual. The light wasn't steady. It flickered in patterns that repeated with perfect precision. Every few hours, the brightness rose and fell as if following a rhythm. No natural object in space had ever behaved this way. Researchers rushed to explain it. Some believed the pattern came from the comet's spin. Others thought it was gas bursting from cracks in its surface. but the timing was too regular, too exact. The light didn't scatter randomly. It looked deliberate. The idea that the glow might be controlled sent shockwaves through astronomy. If the light wasn't random, it meant something inside 3i Atlas was organizing it. Teams began comparing the new Chinese data with older Western records. When the graphs were overlaid, an unexpected connection appeared. Each time Earth-based radar systems sent strong signals toward the object, the comet's light changed slightly a few hours later. The variations were small but consistent. To many scientists, it looked like 3i Atlas was reacting. Some dismissed it as coincidence, but others were not so sure. If the object came from another star system, could it be responding to electromagnetic waves? Independent researchers tested the idea with different models and kept finding the same result. The brightness peaks aligned with human activity. It was as if the object was listening. Chinese officials avoided public comment, yet state-run media hinted at unusual internal activity. That single phrase ignited global debate. Some said it referred to chemical reactions under the surface, while others argued it was a cautious way to describe something artificial. Online forums exploded with comparisons to Oumuamua, the mysterious interstellar body that had sparked similar controversy in 2017. Harvard astrophysicist Avi Loeb once suggested Oumuamua could be a probe. Now, 3i Atlas seemed to raise that possibility again, but with stronger evidence. One set of frames especially drew attention. Over 6 hours, the brightness pulsed 3 times at 11-minute intervals. Those bursts matched the duration of standard deep space communication tests. When this pattern became public, it caused an uproar. Was this mere sunlight, or had humanity unknowingly triggered a response? NASA offered no statement, and the European Space Agency remained quiet. Independent observatories tried to confirm the pulse pattern using smaller telescopes. Some detected faint variations, others found none. Each result only added confusion. More curious still, later Chinese observations showed subtle changes in color, tiny shifts in wavelength that suggested internal heat or energy. To some experts, the object no longer looked inert, it looked alive. The idea of a self-regulating object terrified and fascinated everyone at once. If the data was accurate, 3i Atlas was not a random mass of ice and dust. It was a system capable of reacting to light, energy, and possibly even observation. Scientists called for more verification, but the silence from Western observatories left the Chinese interpretation uncontested. For the public, speculation turned to awe. Was 3i Atlas simply a fragment of another world, or was it something built to travel between stars? No one knew, but as the object continued its silent journey through the solar system, one question began to echo through every laboratory and newsroom. If it truly reacts to us, then what message is it trying to send? As the mysterious images of 3i Atlas continued to circulate, another story began to unfold, one that had less to do with science and more to do with control. For decades, the West had dominated the skies through its vast network of observatories, satellite programs, and open-access databases. But now, for the first time, China held the most important data in astronomy, and it was not clear how they intended to use it. The release of their images had shifted the balance of power, forcing scientists and governments alike to question who really owned the story of the universe. Inside international research circles, tensions quietly grew. Western institutions were used to leading global discovery, sharing data freely through long-standing cooperation treaties. Yet when they reached out for access to the full Chinese dataset, they found the door closed. China's observatories were operating under national security protocols, and raw data could only be reviewed by approved research partners. The message was subtle but unmistakable. The age of open astronomy was changing. This wasn't just about one comet, it was about control of information itself. The right to capture, analyze, and interpret data was becoming a new form of soft power. Whoever released the first findings would shape how the world understood the event. The Chinese media framed the discovery as a symbol of technological strength, calling it a milestone for independent space science. Meanwhile, Western headlines carried a more anxious tone, hinting at the growing divide between open research and state-controlled science. Behind closed doors, government agencies began calculating the implications. Space had always been the ultimate neutral ground, where scientists from rival nations could still collaborate. But this incident blurred the line between exploration and competition. If one nation could monopolize an interstellar event, what would stop others from doing the same? Discussions in the European Union and NASA focused on building more resilient, distributed telescope networks that could not all go offline at once. The silence that had given China its opportunity had become a strategic warning. Within China, the mood was triumphant. The state-run space agency announced plans to expand its observation program, promising new ground-based telescopes across Asia and even a dedicated orbital observatory to monitor future interstellar visitors. Funding for international collaborations was quietly redirected toward national projects. For many young scientists in China, this was a historic turning point the moment their country had not only joined the front line of discovery, but taken the lead. But with leadership came scrutiny. Western experts began questioning whether China's images had been fully verified. Without independent access to the original files, confirmation was impossible. Rumors spread that key frames had been selectively released, highlighting features that fit Beijing's preferred narrative. Whether true or not, the perception alone was powerful enough to shape global opinion. It showed that science, once considered universal, could now be used as a geopolitical tool. Meanwhile, smaller nations found themselves caught between two worlds. Countries in South America, Africa, and the Middle East, which often relied on data from both sides, faced a difficult choice: align with the openness of Western research or the speed and structure of China's growing scientific empire. The discovery of 3I Atlas had become more than a mystery. It was now a test of loyalty in the new age of space competition. By the time the world realized how much had changed, it was already too late to reverse. The skies, once a shared laboratory, had become another battlefield of influence. And as China prepared its next wave of deep space missions, one question began to haunt every major observatory on Earth. When the next interstellar object appears, who will have the right to look first? By late October, the mystery surrounding 3I Atlas reached its breaking point. The object was now moving closer to the Sun, where heat and radiation should have torn it apart. Instead, it remained intact. Astronomers watching from Earth and Mars noticed something even stranger. While normal comets accelerated under solar pressure, 3I Atlas slowed down. It defied gravity, drifted against expected trajectories, and emitted bursts of light that no one could explain. Every law of celestial mechanics said it should be breaking apart, yet there it was steady, glowing, and seemingly deliberate. The data shocked even veteran scientists. According to heat models, an object of that composition should have disintegrated days earlier, but thermal readings from the European Space Agency showed stable temperatures across its surface. There were no signs of melting or fragmentation. Instead, the object seemed to regulate its heat, cooling down when exposed to sunlight and warming up when in shadow. It behaved like a machine managing its own energy balance. The possibility sounded absurd, yet the numbers were undeniable. Something was controlling its internal temperature, and nature alone couldn't explain it. As more images arrived, a new detail emerged. Beneath the glowing coma, researchers detected a faint geometric pattern thin, repeating ridges aligned in almost perfect symmetry. It looked nothing like cracks or random formations. The structure curved around the object's core, forming what one analyst described as a spiral grid. At first, skeptics argued it was an artifact from digital processing, but when the same pattern appeared in raw frames from multiple telescopes, doubts began to fade. For the first time, scientists were forced to ask whether they were still studying a comet or something entirely different. Amid growing confusion, NASA quietly resumed limited observation. Using radar data from its deep space network, they confirmed the deceleration wasn't random. The object's velocity changed in short, precise bursts, suggesting small but intentional thrusts. The pattern didn't match natural outgassing, which tends to fluctuate gradually. Instead, it showed controlled adjustments, as if the object were correcting its path. To the public, NASA remained silent, but internal memos leaked to journalists described the findings as anomalous and possibly artificial. That phrase set the internet ablaze. Meanwhile, China maintained full observation, releasing another batch of data that appeared to verify the same conclusion. Their measurements showed that 3I Atlas's motion was synchronized with specific solar angles, implying that it reacted not to heat itself, but to sunlight's orientation. It was as if the object understood its environment and adapted accordingly. The world had never seen anything like it. For decades, scientists had speculated about technosignatures, traces of alien engineering too subtle to recognize at first glance. Now, for the first time, humanity seemed to be staring at one. Still, there were other possibilities. Some experts proposed that 3I Atlas was a fragment from a planet-sized body with exotic chemistry, possibly ejected from another star system. Its layered shell and geometric features could be the result of extreme pressure or magnetized minerals. Others speculated about a natural crystalline structure capable of storing and releasing heat in rhythmic cycles. These theories were fascinating, yet none could explain the deliberate path corrections or consistent symmetry. Nature could be creative, but not precise. As the debate raged on, one undeniable truth emerged. 3I Atlas had rewritten the rules of astronomy. It wasn't just a visitor from the stars, it was a question that science couldn't yet answer. Whether it was a probe, a relic, or a cosmic accident, its existence forced humanity to confront something bigger. If this object wasn't supposed to exist, what else could be out there, moving silently through the dark? And when we finally meet the next one, will we even recognize it? As 3I Atlas drifts back into the dark, it leaves more questions than answers. The data gathered across months of observation has rewritten what scientists thought they knew about the cosmos. It proved that the universe still holds secrets capable of shaking human certainty. Some believe 3I Atlas was a message, others see it as a warning, but everyone agrees on one thing: it should never have existed, and yet it did. In a world where technology allows us to see farther than ever, this object reminds us how little we truly understand. Maybe it wasn't just passing through, maybe it was watching us too. And if 3I Atlas was only the first of many visitors, the next one might not stay silent. So the real question is, when the sky speaks again, will we be ready to listen?